Hey everyone! Today, we're going to take a gentle look at a really core idea in programming. Basically, how code decides what to do next. This isn't going to be a heavy lecture or anything. Think of it more as just exploring the simple building blocks that make all of our software feel so smart. We're talking about control statements.
Have you ever stopped to wonder about that? You click a button, maybe you fill out a form, or you're playing a game, and the program just knows how to react. It feels dynamic, almost like it's thinking. So how does it do it? Well, the answer is actually way simpler and more elegant than you might think.
You see, at its most basic level, a program is really just like a recipe. It does step 1, then it does step 2, and then step 3, right on down the list. This is called sequential execution. It's kind of the default setting, the simplest path a program can take.
But what if we don't want to just follow the list from top to bottom? What if we need to make a choice, or maybe repeat a step a bunch of times? That's where program control comes into the picture. It's how we, as the creators, get to be the directors of the show, specifying the order of things and making our programs feel alive.
Okay, so let's dig in. And what's really amazing is that researchers figured out that any program, and I mean any program, no matter how ridiculously complex, can be built using just 3 basic structures. We already know the first one, sequence. That's just doing things in order. The other 2, selection and repetition, well, that's where the real magic starts to happen.
So let's start with the most fundamental way a program can possibly make a choice. It's called a selection structure, and the version you're going to see everywhere is the if-else statement.
At its very core, it's just a simple binary decision. It's a fork in the road. Should the program go left or should it go right? Should it show a success message or an oops, something went wrong message? The program gets to a point where it has to pick one of 2 paths and only one.
And here we can see exactly how that works in the code itself. The program looks at a condition. That's the bit right there in the parentheses. If that condition turns out to be true, it runs the first block of code. But if it's false, it completely skips that first block and jumps down to run the code in the else part. It's always one or the other. It can't be both.
And here's a perfect real-world example. The program asks a super simple question. Is the student's grade greater than or equal to 60? If the answer is yes, boom, it displays passed. If the answer is no, it displays failed. Seriously, every time you see a pass-fail result on anything, this is the exact logic working its magic behind the scenes.
Now, this is where it gets really interesting, because it connects right back to us, the users. When a website pops up a little box asking, "Are you sure?" with an OK and a cancel button, your click is what makes the condition true or false. Clicking OK might set the condition to true and submit the form, while clicking cancel sets it to false, stopping the action. You are literally guiding the program's choice.
Okay, so making choices is one huge part of controlling how a program runs. But what about all those jobs that need to be done over and over and over again? That's what computers are amazing at, right? Doing the same thing a million times without ever getting tired. This is where we bring in the power of repetition, or as they're known in the coding world, loops. Just think about it. Imagine you need to apply a filter to every single pixel in a photograph. Or think about your social media feed. How does it just keep loading new posts as you scroll down? That's a loop. Trying to write out the code for each and every one of those actions one by one would be absolutely impossible. We need a way to just tell the computer, hey, do this, but do it like 1,000 times.
The logic behind a loop is actually, it's very human. Before we even peek at the code, just think about how you'd count to 10. You'd start at 1, then you'd check, am I at 10 yet? Nope. Okay, perform the action, say the number, then you add 1 to your mental count and you do it all over again. That's it. That's the heart of a loop.
And here is what that same logic looks like as code. This is called a for loop. And it's so cool because it packages all those steps we just talked about into one tidy line. The first part, it sets our starting point. The second part, in the middle, that's the check we do every single time to see if we're done. And that last part, that's just how we add 1 to our count after each round. It just automates the whole thing for us. It's really elegant. So we can make a simple this or that choice and we can repeat actions. But what happens when a decision has a whole bunch of possible outcomes? That's when we need to pull a different kind of tool out of our toolbox.
Because it's true, right? A choice isn't always a single fork in the road. Sometimes it's more like a big intersection with multiple exits. Think about choosing a difficulty level in a game. You've got easy, normal, hard, maybe nightmare mode, or picking a country from a drop-down menu. There isn't just one condition to check. There are a whole bunch of possibilities.
This is where something called a switch statement is incredibly useful. What it does is it takes a single variable and compares its value against a whole list of possible case labels. If it finds a match, let's say case 0 here, it runs the code for that specific case, and then the break statement tells it, okay, you're done, get out. And if it goes through the whole list and finds no matches, it can run a default case as a fallback. It's just a really clean, organized way to handle those multiple choice situations.
So we've looked at if-else statements, we've looked at loops, and we've looked at switch statements. Let's just take a step back for a second and think about what these things really are.
And honestly, this is the most important thing to take away from all of this. Please don't think of these as just some boring syntax rules you have to memorize for a test. Think of them as the basic vocabulary, the grammar even, for how you communicate with a computer. With just these simple tools for making choices and repeating actions, you can build the logic for pretty much any task you can dream up. I really love this quote from Einstein because it feels so fitting here. It reminds us that even though programming is built on this very precise, countable logic of true and false, ones and zeros, the things we create with it, the solutions, the art, the connections we build, they can have a value that goes so far beyond the code itself. So, the next time you use an app or browse a website, maybe you'll see it just a little bit differently. Maybe you'll notice the simple yes or no questions and the little repeating patterns that make the whole thing work. And with that little bit of understanding, maybe you'll start to ask yourself this question. Thanks so much for spending some time with me today.